This is S.K. Ghosh. I would like to welcome you to our web seminar today, Significant Changes in ACI 31819. Today is the third part of our three-part seminar. We will start with chapter 23, Strat and Tie Models, and go through to the end. The very first slide I have shown you the last couple of times, the cover of ACI 31819, almost identical to that of ACI 31814, except for the bit of color here. And I did mention both times that inside the book you will find a lot of color. The figures are now all colored. I think that has added quite a bit, and the section head, the page headings and so forth are in color. So that is a difference that you will notice right away. I also showed this slide the last couple of times. We have in 31819 a large number of substantive changes of far-reaching consequences. I use those words deliberately, substantive and far-reaching. And this will require significant learning and adjustment on the part of the practitioner. So we did part 1 of the seminar, chapters 1 through 17 on Wednesday, June the 3rd. We tried to do part 2, chapters 18 to 22 on Wednesday, June the 10th. Did not succeed in going all the way through, so we finished it yesterday. And then part 3 is today, June the 16th. As I mentioned, we will go from chapter 23 to the end. The end is now Appendix A following chapter 27. So we will start with the Strat and Tie models, chapter 23. Quite a few changes actually in this chapter. Revisions in how to incorporate pre-stressing force in Strat and Tie models. New factor beta sub c for struts and nodal zones to account for concrete confinement. So this is a brand new factor. Revisions in the strut coefficient beta sub s. We will look at some details on each of these changes. Revised provisions for controlling diagonal cracking in struts. Then new provisions for what are being called curved bar nodes. And finally, brand new provisions for seismic design. This is in chapter 23, Strat and Tie models. The first change, pre-stressing. So pre-stressing effects are to be modeled as external loads now to produce a realistic flow of forces in the Strat and Tie model. And I will take you to the next slide where we have a figure. And because we are doing this, pre-stressing effects are being modeled as external loads. The equation to determine tie strength is revised. You will see that in just a minute or so. So in 31814, when we had a Strat and Tie model, if there was pre-stressing in a member, that was considered in the strength equation that I'll show you very soon. In 31819, the pre-stressing force will be an external force as shown in the picture. Okay. Now, application of this external load may do something that is pretty important. Okay. So in 31814, this definitely was a tie member. Okay. In a truss, that is a tie, that is the strut. Now, when we apply this pre-stressing force as an external force, this tie member changes to a strut. Now it is under compression. So that sort of thing can happen or is liable to happen. The Effects of pre-stressing shall be included. This is the specific language in the section that you see. The effects of pre-stressing shall be included in the start and tie model as external loads with load factors that are given in chapter 5, and I will show you that in a second. For pre-tension members, those are, as I said, the plant-made precast as opposed to post-tension, which is site cast. So for pre-tension members, it shall be permitted to assume that the pre-stressing force is applied at the end of the transfer length. Transfer length is the length it takes to transfer the effective pre-stress to the concrete. Okay. So we will consider the pre-stressing force to be applied at the end of the transfer length.